From the studios of Postscript Media and Canary Media.
I'm Shayle Khan, and this is Catalyst.
So instead of actually the electricity being the product, which is what we've been used to for 20 years, we now can turn it into clean hydrogen. And if that's not enough and there's not enough takers for the clean hydrogen at a bankable contract, well, we'll turn it into green ammonia.
Right, we're selling molecules, not electrons. That's the idea. This week, what would be the biggest hydrogen storage project in the United States gets a $500+ million potential loan guarantee from the federal government. This thing is ACES.
Let's face it, environmental news is often very depressing. That's why we focus on solutions on this podcast. But still, the climate crisis looms large. Rising temperatures, mounting pollution, environmental degradation, they're all warping the planet. And for a lot of species, including us, things don't always look so great. But the story doesn't end there. Every Friday, Living Planet, a show from Deutsche Welle, takes you behind the headlines to figure out what's happening and how we'll get through it. It'll also help you make better choices for a healthy planet and find space to reconnect with the beauty and wonder of the world around us. You can find Living Planet wherever you get your podcasts.
I'm Shayle Khan. I'm a partner at the venture capital firm Energy Impact Partners. Welcome. Just as a reminder, we are trying out a mailbag episode coming up on this podcast. If you want to ask any questions, really any questions whatsoever, we've already gotten a bunch, and I will admit you people think I know much more than I actually know. With that said, continue to ask tough ones. Just tag us on either Twitter or on LinkedIn with the hashtag AskCatalyst. Now on to today's episode. Picture this. You're in Delta, Utah. Population just over 3,000. You're not there for the scenery, beautiful though it is. You're there because it is home to 1,000 megawatts of electrolyzers, producing more than 450 tons per day of green hydrogen, storing all that green hydrogen in salt caverns, which can hold more than 5,500 tons at a time, the equivalent of about 150 gigawatt hours of energy storage. For reference, we have a total of less than 2 gigawatt hours of energy storage in the US overall. Some of that hydrogen is powering what used to be a 1.8 gigawatt coal power plant nearby that is now running on a blend of natural gas and hydrogen and eventually will run entirely on hydrogen. The rest is then piped around for a variety of applications from the power sector to industry and heavy-duty transportation. You hear about stuff like this, and if you're like me, you often dismiss it initially just because of the sheer scale and magnitude and the complexity of getting something like this done. But the DOE Loan Programs Office is not in the business of making loans or loan guarantees to pipe dreams. So it's notable that the LPO just issued a conditional commitment to guarantee an over $500 million loan to the ACES project, which would become the largest green hydrogen hub in America by a long shot. The loan itself will actually come from the U.S. Treasury's Federal Finance Bank, and then the LPO is offering a conditional commitment to guarantee that loan. So this week, we've got a familiar voice, Jigar Shah, head of the Loan Programs Office, back on the pod to talk about this project, the messy midstream of hydrogen, and what it might all mean for power and industrial decarbonization. So here's Jigar. Jigar, welcome back.
It's great to be here.
It is great to have you again, and congratulations on the third new loan or loan guarantee announcement of your tenure. Is that right? We're up to 3 now?
Yes, we've been doing a tremendous amount of work behind the scenes to get the office primed and ready. And so I think that you'll hear more announcements going forward.
Right. I expect the pace to accelerate. But I'm excited to talk about this one because it's, I had heard about this ACES project just in announcements, but didn't really have a clear sense of how realistic it was or actually like how it's going to work. So I'm keen to dig into it with you. So maybe let's start with that. Walk us through the ACES project, what it is intended to be, and then we'll talk about all the nuances that it brings.
Yeah, no, it's an exciting project, right? And one that has been working behind the scenes for a long time. I think there actually has been a lot of press and conversations about it, but it's been mostly in the trade press, I think. But, in short, it's an 1,800 megawatt coal plant that was there before, and it happens to sit on top of a salt dome, and so this salt dome is in a great place to be able to store hydrogen, and there are changes that have to be made to the salt dome to be able to store it well. And then there's electrolyzers that convert electricity into hydrogen, and there's a lot of water that got freed up from the coal plant shutting down, and so there's some water rights and water availability there. And there's an off-taker, right, that's willing to pay the capacity payment for putting this together in Intermountain Power. So there's an ability to actually to finance the project because there's somebody who actually wants to provide a capacity payment and money for the peaker, for the peaking electricity. And then, then that group is actually then remarketing, this to other players, right? Whether in California or other places, right? So the four corners of the project are really a power project fundamentally. But the part that I find fascinating is that once you build the green hydrogen, right, you're now in a situation where it may not actually be the most valuable thing to turn it into power. Right. So it could end up being that, someone calls them up and says, hey, I want to make green ammonia here. Could I co-locate at the facility? And so the amazing thing about the project is it's just the start, but it has a lot of possibilities.
Yeah, this is one of the things that I find really interesting. I want to talk about these hydrogen hubs that are spinning up. This would be one of them. You've seen more announcements around these in Europe than we have in North America so far. But I think this is one of the, 2 or 3 big hydrogen hubs that seem to be emerging here. And they're multifaceted, which I find pretty interesting. So just to walk back through it. So we'll have a bunch of electrolyzers that are going to convert electricity and water into hydrogen. That hydrogen gets stored in the salt domes that happen to be in Delta, Utah. And then some of that hydrogen, you're saying, will be used to repower this 1.8 gigawatt coal plant, but not all of the hydrogen. And then the rest of the hydrogen can get diverted for other uses, either piped somewhere or producing something else on site. Do I have that right?
To date, the offtake really is power. Right.
So you're underwriting to this capacity contract for the power.
That's exactly right. We're underwriting to the power and the renewed generation facility will be owned by Intermountain Power Agency. And so that is what we're underwriting to.
And yeah, let's talk about the power then for a second, then we'll get to the other stuff. So we've got the coal plant is operating today, right?
The coal plant has been slated to be shut down, and so it should be. It's either being shut down this year or very soon.
So this coal plant will get shut down and then repowered. And as I understand it, at least from the articles that have been written about this ACES project, the way they're thinking about doing it is that repowering it on day one with a blend of natural gas and hydrogen, with the hydrogen share increasing steadily over time until ultimately by 2045 or something like that, it becomes 100% hydrogen generation. Is that right?
Yeah, that's right. Is that there's an 840 megawatt natural gas plant. Our money is not being used at all for that. So our money, the project that we're funding is an electrolyzer project using a salt dome as storage, right? So none of our money is going to a new natural gas facility. That natural gas facility is supposed to be using an initial blend of 30% and then ramping up to 100%, which they think they could do as soon as 2030. But I think that as you and I look at the marketplace, right, the role of peaker plants is going to be moved increasingly to emergency situations. Right, that you've got battery storage and lots of other technologies that are being used inside the Intermountain West to be able to provide these sort of services. And so peaker plants, in the new modern grid should be used less and less, during wildfire season or polar vortexes or things that may occur, right? And so my sense is that hydrogen then could be repurposed at that point to higher value things.
That's interesting. Yeah, we've heard, or at least I've heard a lot about repowering natural gas plants to operate on a blend of natural gas and hydrogen. And then a lot of them say this sort of blend will be increasing over time. Eventually, it'll be powered entirely by hydrogen. I don't think I've heard of so many coal repowerings to natural gas plus hydrogen, which makes this one sort of interesting to me. But a coal plant is obviously not a peaker, right? Fully baseload
That's
resource
right.
doesn't ramp. So it's already switching from a baseload resource to a rampable peaking resource, which is what the natural gas plant is going to be.
Which allows you to free up the transmission capacity to be able to be used for other purposes, right? And so that's the interesting thing about this is that, you've got a lot of curtailed power. I mean, you saw that, I think last week there was this phenomenon in California where, you had positive prices in parts of the state, and California ISO was paying people to turn off their systems in other parts of the state.
It's the Texas phenomenon. You constantly see this in Texas, right? Where East Texas and West Texas have exactly opposite power prices.
So you could see power flows actually reversing from California to this facility in Utah to be able to use a lot of the excess power generation that's available from California to be able to rely on lower cost electricity to be able to electrolyze that electricity into hydrogen, right? So the electrolysis load will be largely continuous because that's how you get the most out of the fixed hardware that you're putting in. But you can imagine that it actually creates a different power flow dynamic in the region.
You've got, from a financial perspective, it sounds like you've got a long-term, credit-worthy, fixed-price off-taker for the capacity.
Yep.
Right. So that the financial component is pretty well de-risked. What about the tech component? Do you think there's anything here? I mean, these big salt domes are fairly well understood, but we've not really stored a ton of hydrogen in them historically.
Yeah. So, I don't think there's ever been a salt dome repurposed for hydrogen in this way. And so there's certainly been test facilities that have been built in the past. But to our knowledge, there's never been a commercial hydrogen storage salt dome. So this will be a first of a kind there. On the electrolysis equipment, this is fairly robust equipment. I think it's been around since the 1950s. I don't think the process itself is risky in any way. Certainly they're going from, I think, a 3 megawatt size to a 5 megawatt size. And so it's first of a kind from the new size. But I don't think that anyone believes that part of the project will be risky. But it is exactly where 10,000 engineers, scientists, and experts play at DOE, right? Is that you could imagine a commercial bank getting comfortable with the electrolyzers, but not getting comfortable with the salt dome. And, we've had our best people working on this at the Department of Energy, and they believe that the way in which we'll be upgrading the salt dome to make sure that it can, store hydrogen will work, right? And so from that perspective, it is something uniquely that the Department of Energy's Loan Programs Office can do, because a lot of other folks will say, it's not our expertise. And even though I have an independent engineer telling me that it'll work, I still am not going to get comfortable with this approach. And so from that perspective, I think it is uniquely where DOE can play a role for the first of a kind deployment.
Are you financing the build out of the power generation that'll feed the electrolyzer, or is it just grid connected?
Yeah, we're not. You mean in terms of the electrolyzers?
Yeah, is the electrolyzer just getting grid connected and pulling power from the grid, or are they co-locating solar or wind or something like that?
So for the first iteration, they're just getting connected to the grid, and there's going to be a network of contracts and RECs to make sure that it's 100% clean energy. But I think that over time there could absolutely be co-location of other assets that get placed there, but that's not part of version 1.0.
I guess one thing I've been thinking about with all these big projects, particularly for for power generation for hydrogen is, do you need the salt dome, right? Because an alternative would be if you've got a grid-connected bank of electrolyzers, you can run them on demand. Now, to your point, if you want to amortize the CapEx over as many generation hours as possible, then you want to be running it baseload, basically. But in theory, you don't have to. And then you could just produce basically on demand. You'd have to have a buffer of some storage, but you could basically produce on demand for the power plant. And then you would need to store the hydrogen in the first place. But the idea here is that this is a peaker plant, and so it's not operating at high capacity factor, and you don't want to have to run the electrolyzers at the same time that the plant is running.
Yeah, no, that's exactly right. Right. I mean, when you think about using these kinds of electrolyzers and running them all the time, you really can get below $4 a kilogram for clean hydrogen, right? And so, but that does require you to get affordable electricity, but also very high run times, right? And so I do think that the cost would go up substantially if you were running the electrolyzers only when the peaker plant was running. I think the other piece of this, though, remember, is that if we're going to treat hydrogen and this sort of high penetration variable renewable energy grid as something that is a fixture of the future, then you do need this kind of storage that is really applicable to the entire grid, right? And so when you think about variable renewable energy, obviously you have lower loads in spring and fall, so you have great amounts of overproduction during those time periods, and then you have large amounts of load during summer and winter for the temperature extremes, right? And so I do think that whether it's pumped hydro or whether it's hydrogen or whether it's other things, I do think it's important to recognize that having that level of storage allows for the more advanced business models to achieve itself. So whether it's overbuilding, more wind and solar, or whether it's deciding to spend $1 billion on a green ammonia facility or a green chemicals facility or whatever facility you're putting in for hydrogen matters, because if you're saying, well, it's all going to be real time, it's not clear to me that someone's going to say, yeah, sure, let's just make this a hydrogen hub and let's put a $1 billion, chemical facility next to something that's all real time, right? Because you could imagine that once a salt dome is built out and the 220 megawatts worth of electrolyzers are there, you could add more electrolyzers over time. And some of the hydrogen will be used in real time and never make it into the salt dome. And some of it would be put into the salt dome, right? But having that there makes everyone more comfortable on the robustness of the business model.
Right. That seems like the vision here in the articles that were published about this project a while back. They're talking about 1,000 megawatts of electrolyzers eventually, which I think is basically allows for the capacity of the salt dome if you want to fill the whole thing.
Yeah, about 150 gigawatt hours or so of storage there.
Right, which is a ludicrous amount relative to what we've got today.
Yes.
One of the things, so let's talk about these hydrogen hubs, right? I think because again, they're interesting in that it's something that's interesting about hydrogen relative to many of the other resources that you and I have spent the last 15 years talking about, is that hydrogen can serve so many different purposes, right? It can be used in the power sector, it can be used in transportation and industry, et cetera. It's more like natural gas than it is like solar or wind. And so what we're starting to see happen is this kind of hub emerge, in this case, around a storage asset, right? The core of this, I guess the combination of storage asset and existing coal plant that needs to be repowered, right?
Yeah,
so that's
you've got the interconnection, which is a huge deal, right? I mean, the grid already lives around this site.
So you find this site that has kind of the core characteristics that you need to be able to actually underwrite to and finance a fairly sizable deployment on day one, but then with the potential to expand it and then use a bunch of other things. Do you think of it as being, from just like a structural perspective, there's a project developer that has developed ACES, the storage asset, and then finances everything else around it? Or how do you think about the ecosystem of players that have to be involved for this to work at scale?
Yeah, there are many ways of starting this conversation, and all of them are equally confusing. So we can just pick one and then we can go from there. I'd say that in Mitsubishi's case here, from the conversations that I've had with them, they've been pretty clear about the fact that the salt dome is what they were solving for, and that there are 12 or 15 more salt domes like this around the West. And so this is a model that might be replicated. I think that separately, when you think about hydrogen, I think everyone acknowledges that moving hydrogen is a pain, right? Like whether you're blending it in natural gas pipelines or whether you're liquefying it and sending it through trucks or whether you're, just doing compressed hydrogen or whatnot, like moving around hydrogen at scale is not something that we're looking to do at the same level of frequency as we're currently doing with natural gas, right? I mean, and even with natural gas, which is a much easier molecule to handle, you think about methane leaks and how prevalent they are. Doing it with hydrogen would be even harder, right? And so I do think that not unlike low-cost hydro and how aluminum plants and others try to co-locate to where those exist, I do think when you think about the industrialization of our country, decarbonization of the industrial capacity of our country, I do think you're going to start to see people navigate towards production of hydrogen very close to the consumption of the hydrogen for that decarbonization process.
Or vice versa, right? You could also describe it as placing consumption of hydrogen near production of hydrogen.
That's exactly right, for sure. And so I think you could see it go both directions, but I do think that that's where we're headed. And so I think this notion that people have of, a nationwide network of hydrogen refueling stations that are going to be, where you're going to, have a pipeline of hydrogen that goes to each one of these, just the practical math of that is not very conducive, right? So then you end up with, liquefied hydrogen, shipments, which generally is very hard to do at less than $8 or so a kilogram of hydrogen.
Right, or you turn that hydrogen into ammonia or methanol or something like that and ship that stuff around. I think all these questions are sort of remain open, and one of the things that's interesting about hydrogen is because you can make it a bunch of different ways at different scales, there is this trade-off, this balance between where is it going to be cheapest to produce and store versus where is it going to be consumed at scale. And if you assume both of those things are fixed sets of locations, then your ideal is where they overlap, and then your next ideal is where they're close to each other. But if you assume both of those things can be shifted around, you can produce hydrogen at different places, albeit at different costs. And probably more importantly, you can consume hydrogen at different places because it just depends where you're either placing your facility that's using it for some end use or turning it into some hydrogen carrier that you're going to ship around. Then it gets even more complicated and confusing, as you said.
Yeah, no, I mean, there are layers of complexity here. And so, for instance, on the ammonia side, right, our swing producer on ammonia is really bringing in Russian gas via Ukraine fertilizer into the port in Tampa and then sending that by pipeline to Louisiana and then sending it from pipeline from Louisiana up, right? And when you think about where the cost of ammonia and fertilizer is today, it's through the roof, right? Such that, I think green ammonia today is quite profitable without any subsidies at all, even at today's cost of hydrogen, right? And so the question then becomes what is the virtue anymore of thinking about hydrogen as needing to achieve the lowest possible cost and trying to achieve $1.70 a kilogram or whatever it is for hydrogen, versus figuring out, what is the value of the end product and what is the value of being able to get rid of the volatility in the cost of that end product as we continue to produce way more electrons, right? Remember that we've got Bitcoin miners that have basically been thrown out of China and Russia, who are now going across the United States trying to sop up all the excess, electricity capacity and claiming that it's great for the country, right? And, you could imagine there's a lot of other value-added things we could do with all that excess electricity capacity, including making fertilizer here in this country, right? So
we've talked about this before, and I've keep noodling on it. One of the fundamental dynamics that makes that challenging, I think. So let's just assume you do have all this excess generation that's going to come more and more out of wind and solar at the times when it's not needed, and assume we don't build enough long duration storage to like totally soak all of it up and reuse it on the grid. Then yes, there are going to be these times when you have super cheap or zero cost or negative cost electricity. And how great would it be to run your big industrial process just at those times? But it's hard to find, I think, big industrial processes where the ratio of CapEx to electricity OpEx is so low that it makes sense to operate intermittently. Right? Like this is the thing. What you need for it to make sense for you to do that is you need a process for which the electricity cost dwarfs the amortization of the CapEx, because then it makes sense for you to turn off when you don't have that really cheap electricity. Otherwise, your incentive, and this is my issue with the Bitcoin miners too, their incentive is basically to operate 24/7 because it's super lucrative to do so even at higher electricity prices. So they don't really have any reason to shut off, in which case they're not really taking advantage of the excess renewables. They're just operating like a base load resource, right? So there's like very few things that feel like they're like that.
Yeah. Well, so remember, I think that the conversations that we have sometimes get lost in current state versus future state. And so in the current state, it is very easy to map locations where 90+% of the hours, you're actually sitting in very low cost electricity, right? Sufficiently supplied electricity grid. And remember, for a lot of the announced projects in the country, they're talking about $30 to $34 a megawatt hour for the power, right? They're not talking about $12 a megawatt hour for the power. So you're in a situation where 90+% of the cases, you're actually sitting in pretty low cost power. And then for the 5 to 7% of the hours of the year where you start to go above $60 a megawatt hour, you can just turn off, particularly with PEM electrolyzers. Obviously, alkaline electrolyzers are less easy to turn on and off, but you can turn them on and off sort of more week by week, right? And so today, those are easy places to find. And then as you move closer to 2035, and the Secretary's goal of, reaching $1 per kilogram from clean hydrogen, you could imagine you could get more locations that can handle a 60% capacity factor versus 90+% capacity factor, right? But today, when you look at what the clean hydrogen folks are chasing, they are finding many, many, many locations across this country where you can average less than $35 a megawatt hour for 90% plus of the hours of the year on the LMP. So I don't think finding those locations with really high, hours of the year that are low priced is hard to find, right?
Yeah, and it's also a balance. The cheaper you can make your electrolyzer, the lower your CapEx, the easier it is for you to operate intermittently. The higher your CapEx, the more incentive you have to just run all the time. And so the problem with electrolyzers historically has been their capital, and they're really expensive, both alkaline and PEM. And so it wouldn't, even if you could ramp them, you wouldn't want to ramp them because it's too expensive to turn them off. You need to buy down that cost of the capital. But as we get better technology and as the learning rate starts to hit and we get cheap electrolyzers, then that whole equation starts to change.
Yeah, I think that's right. I mean, I would say that electrolyzers are easier to predict lower cost just because they are a manufactured item, and so it works directly within the learning curve approach that we've all come to know and love. But the other thing I would say is it's important for us not to put the entire responsibility for managing the grid onto hydrogen. I think there are many industrial processes, including fertilizer, for instance, that are seasonal in nature, right? I mean, fertilizer is made, the plants that run to make fertilizer in this country are run like 4 months of the year, right? They're not run all year round. So when you think about industrial processes that are more seasonal in nature, they do exist. I think so that's on the demand side. And then the other piece of it is, as you move towards the president's goals of 50% of all new cars being electric by 2030, you could imagine that many of the day-to-day and week-to-week storage actually could be done through electric vehicles, because the battery capacity there just dwarfs what we're putting onto the grid today, particularly in the lithium-ion space, which you could imagine a lot of lithium-ion battery capacity is going to be unavailable to the grid capacity marketplace once autos are ramping up. I mean, you're already seeing a shortage of battery capacity for lithium-ion for autos, and you could imagine they're willing to pay a higher price and provide long-term contracts for that capacity. So if you're a battery manufacturer, you'd rather an automaker as an off-taker than a grid provider.
That's actually, I mean, this is getting onto a different topic, but I worry a lot about that. I mean, we're currently facing like rising prices for lithium-ion batteries, both because of supply chain, bottlenecks and COVID and all that, and also because of rising prices of commodities, lithium, nickel, et cetera. But to your point, if that persists, then it probably hurts the grid storage market even more than it hurts the EV market, just because of where, if all things equal, which market do you sell into if you're a battery OEM? So while we've been really, I think, excited around the role of stationary storage for the grid, I worry that we're actually not going to be able to deploy nearly as much of it as we think we're going to. Just, this is a temporary phenomenon. Long term, this gets solved, presumably, but over the next, 5 years, like, is there a crunch there? And does it mean that we're going to have a mismatch between the need for the short-term storage, the diurnal, 4-hour type stuff, versus the actual supply in the market?
Well, I think that, like, when you think about where DOE is, right? I mean, DOE has had battery storage chemistry, research since its inception, right? And so, Form Energy has been using sort of an iron, sort of formulation that we rejected for automotive uses way back in the day. When you think about zinc formulations and iron formulations, there are many. And so I don't think we have a challenge around diversity of battery chemistries. This is not the same as solar, where you've got like sort of a domination of crystalline, and then you've got, the CadTel from First Solar. Batteries should and will go into very diverse approaches. And on the chemistry side, I think the challenge we've had is because lithium-ion got a head start, because, from an iPhone's perspective, right? You literally have no supply chain issue at all, right? I think the cost of a battery, the lithium, in a battery is like 50 cents or something like that, right? Isn't that what your last podcast said? And so if they triple that to $1.50, it doesn't matter for your $1,000 iPhone. So lithium-ion got to scale first, but when you think about the zinc-based chemistries and the other based chemistries, they have the same learning curve as lithium-ion batteries, right? And so I don't think that having affordable batteries with non-lithium supply chains is actually going to be very hard for us to do. And many of those companies have SPAC'd, right? So they've actually already raised capital from the private markets and are starting their first manufacturing facilities. So, 5 years is probably how long everything takes. But I don't think we're, always 5 years away. I think we're actually 5 years away from all of those technologies being available at scale to the marketplace. But that's why these projects like the ACES project in Utah are so important, right? Because I think everyone wants a solution right now. And they're basically saying, please map out every single month between now and 2035 and how we're going to decarbonize the grid, because that would make my life a lot easier. And I totally agree. It would certainly make my life a lot easier. But it's not the way that the world works, right? And so we need projects like what's happening in Utah to occur. And we need, folks like Intermountain or LAWP or others to say, we're going to try weird and interesting things, or what appears to be weird and interesting. I don't think it's actually that weird, although it is interesting. And then we're going to need to see whether this approach is actually a better approach within an integrated resource plan that the utility is putting forward to finally put the details behind their decarbonization goal by 2050 or 2030 or 2040, right? And so I do think that having these solutions, not just at scale, but in a bankable format, is super important, right? Because otherwise, we're just talking past each other about theoretical concepts that came out of some sort of white paper.
Okay, so that's a good way for me to close out then, which is back to the ACES project. I think you've talked about this before. You have a ton of loan application volume coming into the LPO right now. But for folks who are thinking about what would it take for me to have a project that is attractive? And this is project capital, right? You can also provide manufacturing capital, but let's set that aside. For projects, what are the sort of fundamental characteristics that the ACES project has that are okay, checks all the boxes for us, we can move forward?
Well, the first thing we have is an existing interconnection point, right? Which is hugely important. You can imagine that those are in very short supply today. You also have, access to water because of the existing water rights that were held by the coal plant, right? But you also have a group who's actually willing to do a tolling arrangement, right? I mean, when you think about what's the structure of the project, both the water and the power is being tolled by Intermountain Power Agency, right? And so from a risk standpoint, you don't have to take the risk on power prices, water availability, and all the other pieces in this project, right? So the de-risking thing here is quite substantial. But the other thing I'd say is that as we move forward, right, this project is really well structured. It was rated at investment grade for the loan. So it's actually really well structured. Many of our projects are triple C or single B in terms of its shadow credit rating. And so, but once the technology part of this becomes demystified, then you can imagine there's a lot of wind and solar developers who are saying, we are frustrated by the fact that we have to accept a below market PPA price. Remember, we've had this conversation around whether PPA prices were heading towards zero on utility scale solar and wind projects, right? I think what Sheldon Kimber has said many times on different podcasts, but also many others are now saying, no, we now have option value, right? And so if getting a power purchase agreement becomes difficult at an acceptable price, let's call it $30 a megawatt hour, for the work that we've already done to create solar and wind, and we're integrating it at the grid at this point such that we're depressing the price of electricity at this LMP, we now have the ability to vertically integrate into electrolysis and actually hedge and get a higher price for that electricity feedstock, right? So instead of actually the electricity being the product, which is what we've been used to for 20 years, we now can turn it into clean hydrogen. And if that's not enough and there's not enough takers for the clean hydrogen at a bankable contract, well, we'll turn it into green ammonia. And we'll actually...
Right, we're selling molecules, not electrons. That's the idea.
Right?
Yeah.
And so now you take the world's best developers, right? And America's best developers for sure, but I think these are all world-class companies. And you're saying to them, we're going to give you option value because the LPO came in on ACES and actually has demystified this from a underwriting standpoint, and in fact underwrote this to commercial, investment grade credit. Now, those other companies feel more comfortable to take I forgot the stat that I saw the other day, but it was like over 1,000 gigawatts of utility scale solar and wind and battery storage projects, they're in various forms of regulatory compliance, right? They had issued a desire to put power into the grid here 6 years early or whatever it is. So you've got this gargantuan amount of development that's being done without any clear understanding of what the offtake might look like for that development, right? I mean, let alone the interconnection. So you could imagine in the future even creating a microgrid out of these projects and saying, you know what, even if we don't get interconnected today, we'll stay in the interconnection queue. We'll actually just build a microgrid around this green ammonia project. And then we'll actually interconnect whenever our interconnection queue position opens up. And we can interconnect and we can export power at that point, right? But in the meantime, we'll just create green hydrogen or clean hydrogen at the time, and then, create a finished product out of it, right? Because we've already done all this development work and it's super cheap to generate the power, right? So I just think that people are so myopic in the way that they think about traditional solar and wind models that they think that the price of this stuff is going to zero. But in fact, the option value has now just gone up substantially.
All right, Jigar, fun as always to have you on here and talk about the next project. Can you plant any little seeds for us on sectors we should be looking out for the next wave of LPO announcements?
Well, I mean, we publish every month the monthly activity report. And so I think, we announced our graphite processing loan earlier in April. And so I think you're going to see a lot more announcements on the ATVM program. So this is, battery storage manufacturing, this is EV manufacturing, as well as more critical minerals there. And then on the Title 17 side, right, where it's fossil, nuclear, and renewable energy and efficient energy, I think you're already seeing a lot of pre-announcements around battery, manufacturing for utility scale markets. You're starting to see a lot of virtual power plant applications that are starting to get processed through the office. You're starting to see a tremendous amount of, I think we have $15 billion at this point of sustainable aviation fuel projects that have been proposed to the office. And so I think when you start to, really figure out how much sort of institution building we've been doing for the last year, we're now ready to start taking that institution and start coming out with conditional commitments. So we're excited.
Awesome. Well, we'll have you back again next time we got one that we find particularly interesting. But as always, thank you for joining.
They're all equally interesting in my book.
I'm sure they are. I'm the one who gets to discern. Thanks, Jigar.
Thanks, Shayle.
Jigar Shah is the director of the DOE Loan Programs Office. This show is a co-production of Postscript Media and Canary Media. You can find the show on Twitter at @CatalystPod. You can also find me, Postscript, and Canary there too. And don't forget to send in your questions for our mailbag episode. Just tag Catalyst with the hashtag #AskCatalyst. And send us feedback, as always. If you like the show, go over to Spotify or Apple Podcasts and leave us a rating and review, or just share the episode with a friend. You can find links for this episode's topic and guest in the show notes on canarymedia.com. Postscript is, as ever, supported by Prelude Ventures, a venture capital firm that partners with entrepreneurs to address climate change across a range of sectors, including advanced energy, food and ag, transportation and logistics, advanced materials and manufacturing, and advanced computing. The producers for this episode were Daniel Waldorf and Stephen Lacey, mixing by Greg Vilfrank and Sean Marquand, theme song by Sean Marquand. I'm Shayle Khan, and this is Catalyst.